This system is a DC-coupled solar-to-energy storage system with UPS functionality, offering a stable, practical, and reliable structure. It consists of PV panels, a DC converter, a bidirectional power storage converter, PCs, a filter and voltage stabilizing transformer, a bypass, a grid breaker, a step-up voltage transformer, a 35 kV grid, a diesel generator, and a load. A key feature is that the battery system, DC converter, and PCs are directly connected to the DC bus, enabling efficient energy management and fast switching. Use Scenario 1. Grid-connected operation. During the day, the PV panels convert solar energy into DC power, which is stabilized by the DC converter and fed into the PCs, where it is converted to AC power for the load. Excess power is used to charge the battery. When the battery is fully charged, charging stops, and excess power is boosted by the transformer and fed into the grid. If the grid prohibits electricity sales, the PV power is used solely for load consumption. At night, the battery system supplies power to the load. When the battery is nearly discharged, the PCs controls the battery system to stop discharging. The grid directly supplies power to the load through the bypass, and the load is unaware of the power outage. Use Scenario 2. Off-grid operation, grid outage. During the day, when PV power generation exceeds load demand, the excess energy is used to charge the battery. If the 35 kV power grid suddenly loses power, the system uses the bypass's STS function to achieve a rapid off-grid switchover in less than or equal to 20 milliseconds, unaware of the power outage and continuing to be supported by both PV and batteries. When the photovoltaic power generation is lower than the load demand, the battery and photovoltaic panels will jointly power the load. If the battery power is insufficient and the photovoltaic output cannot meet the load demand, the system will start the diesel generator to power the load and maintain the stable operation of the off-grid system. Once the 35 kV grid returns, the PCs automatically detects that the grid has power, the diesel generator stops working, and the PCs controls the grid breaker to close and return to grid-connected mode. The grid directly supplies power to the load through the bypass. At night, the battery gradually discharges to support the load. When it's nearly discharged, the PC stops discharging and uses the diesel generator to directly power the load via the bypass.